This is homework 4, for heat mass. For the first question, 3-139, we have this pipe right here. We're asked to find the temperature at the base as well as the heat loss from the pipe. First off, we found the area using IDL, and then we solved for our resistances from the resistances inside of the pipe due to the heat transfer. We have two different types of resistances, the conduction and the convection, for the pipe in question. We then use our resistances. We get a total resistance and our temperatures that we were given to calculate temperature at the base using the Q found at the top. Then once we have our temperature at the base, we can then find our Q loss from the base to the surroundings from our pipe. And for that, we're going to be using the resistance of the pipe and not the fin portion to get a Q dot loss term. For question 3-197, we had a fin coming out of a wall with some specs seen above, and we're asked to solve for it 4 different ways with 4 different varying assumptions. For the first assumption, we assumed an infinitely long fin. We calculated a Q given the long fin equation, or given an infinitely long fin equation. Given an infinitely long fin, we then get a heat transfer in wattages for that, as well as a variation in temperature based off an exponential. For the second part, we were to find the adiabatic heat transfer for the fin using the adiabatic heat transfer equation. I can then solve for that value, as well as using references from the heat transfer equation to get the temperature variation. This was then followed for the next question with the correct heat transfer equation and temperature variation, and then solve for one last time for a convection tip fin, as well as the temperature variation for that fin. Lastly, we had this unit right here with varying dimensions. And we were asked to find the 2 surface temperatures, and given some other specifications with an epoxy, find the heat transfer as well as the temperature on the inside and outside of the unit. For the first part, the surface temperature was calculated using a resistance from the total resistance in the unit itself. We could then find a Q and a T1, and then after that we can use the resistance of just the board itself to find T2. A similar process was followed down here, but the critical length was added to the end to account for heat loss outside of the end of the fin. This was then used to calculate an efficiency, and the efficiency can be combined with the area of the finned and unfinned sections to be put into the equation for the base temperature of the unit. After that, we can use the resistance of the board, since we're just looking at the board, and then changing the temperature equaling the heat loss to find the temperature too.